Section 6.2, example 2 on page 433, we have if the radicand of the nth root of a has a perfect nth power among its factors, you can reduce the radical. If you reduce a radical as much as possible, the radical is in simplest form. For example, consider the square root of 24 and the cube root of 24. For the square root of 24, this is the same as the square root of 4 times 6. However, 4 is the same as 2 squared. So we can separate these two into two separate square roots and have the square root of 2 squared times the square root of 6. The square root of 2 squared is just 2. So this leaves us with 2 times the square root of 6. 2 square root of 6 is in simplest form. For the cube root of 24, we have the cube root of 8 times 3. However, 8 can be written as 2 cubed. So if we split 2 cubed and 3 up, we get the cube root of 2 cubed and times the cube root of 3. The cube root of 2 cubed is just 2, and then we have 2 times the cube root of 3. That is in simplest form. So example 2 says, what is the simplest form of the cube root of 54x to the 5th? There are two methods that I'd like to go over for example 2. Method 1 is the one that we just went over that the book would do. So for the cube root of 54x to the 5th, the book is hoping that you realize that 54 is 3 cubed times 2. Now that comes kind of out of nowhere. If you realize that 27 is a factor of 54 and 27 is a perfect cube, then awesome, go ahead and write that right out. If you don't, you might want to use method 2 first. Then they say, okay, well, x to the 5th, we're looking for cubes. Since there's 5 x's, there's gotta be 3 x's in there. So we're gonna write x cubed, and then if we take 3 of the x's, there are 2 left over, so that's x squared. Then they say, okay, let's split this up and take all of the cubes in one radical and anything that's not a cube in the other radical. So they put the cube root of 3 cubed and x cubed in one, and then they multiply by whatever's left over, 2 and x squared. They skipped this step, but I wanted to add it back in. Because we have both cubes right here, we can combine them to get 3x cubed, and then we have the cube root of something cubed. Therefore, we can take just what's in the parentheses, the 3x, and put it outside the radical. Over here, we have the cube root of 2x squared. There are no more cubes left over, so this just gets stuck inside the radical. So your final answer ends up being 3x times the cube root of 2x squared. This expects that you know quite a bit about the number 54 and has you remember how to use the exponent rules. Method 2, on the other hand, is very much like Math 1. So this is how I taught my kids square roots in Math 1. First, we did factor trees. So if you don't know what 54 breaks down into, if you didn't know right away that there was a perfect cube of 3 cubed in 54, this method kind of helps you figure that out. So the easiest way for me to remember to get 54 is 9 times 6. 9 is 3 times 3, and 6 is 3 times 2. 2 and 3 are prime, so we have factored the tree out as far as it can go. So instead of writing 54x to the 5th in my cube root, I am going to write 2 times 3 times 3 times 3. And then I have x to the 5th, so I'm going to write out 5 x's. Now, this is a little tedious, but I got to skip all of this extra work. So now, anytime I see 3 of a kind, I'm going to highlight them. Of course, you don't have to highlight, you can underline, or you can just spot them. I have 3 3's, so that means I get to take 1 3 out, because what that represents is the 3 cubed we had over here. Then I have 3 of a kind for my x's, which would be our x cubed. So I get to take an x out. Anytime you find whatever your index is of a kind, so here we have an index of 3, I found 3 of a kind of 3's, I get to take 1 3 out. I found 3 of a kind of the x's, I get to take 1 x out. Then I have to write whatever's left over. So I have no more 3 of a kinds, I have 1 2 and 2 x's, so those get stuck inside. So that's 2 times x is x squared. So this again gives us the exact same answer, 3x times the cube root of 2x squared. Either method is totally okay. The work written out is method 1 with actually less steps than I showed. And now I would like you to try number 3, simplify the cube root of 81 times x cubed.